Hello everyone, I'm Rajasri, Assistant Professor, Department of EEE, working at MLR Institute of Technology, Hyderabad. And in today's lecture, I'll be discussing three-phase full converter. Okay, we have been seeing single-phase, half-wave converters, half-control converters, as well as full converters. What is the reason why we are actually going to three-phase converters? It is because three-phase converters will be feeding high power applications. So that is the only reason we are going for three-phase full converters. It completely depends upon the requirement. And here, if you see, previously we have seen semi-converters. There we have made use of half of the devices as thyristors and other half of the devices as diodes. Whereas here, all the devices which we are making use of are fully controllable devices, that is thyristors. So that is the reason here name three-phase full converters and with resistive load. And I have already explained how to draw these phase voltages and how to draw these line voltages as well. And if you see, here we are making use of 6 thyristors. That means each thyristor will be conducting for a period of 120 degrees, and pair of thyristors, each pair of SERs will be conducting for a period of 60 degrees. It is because here one complete cycle will be for 360 degrees and divided by, we have 6 thyristors over here. That means each thyristor, each pair of SERs will be conducting for a period of 60 degrees. Hope you understood this. And now, if you see, here we are checking out the waveform for output voltage waveform for alpha is equal to 30 degrees. If alpha is equal to 30 degrees, in that case, here see, this is line voltage where zero crossing is being appeared, and this is equal to alpha is equal to 30 and this is 60. So at this instant called alpha is equal to 30, we are supposed to provide the triggering pulse such that if you see, right from zero crossing, thyristor will be forward biased, but the moment when we provide the triggering pulse, only then thyristor starts conduction. So that is the reason here at this instant we are providing the triggering pulse at alpha is equal to 30 degrees. That means this instant is called pi by 6, where our alpha is equal to 30. I am writing this as pi by 6 plus alpha, and here we are providing the triggering pulse. And R phase, in the sense, this is connected to thyristor 1 and this is the triggering pulse for IGT1. And how long we have provided the triggering pulse? For a period of 120 degrees. Each thyristor will be conducting for a period of 120 degrees. So that is the reason here 60 plus 60, that is 120 degrees. We have provided the triggering pulse, and later this is the another zero crossing, and at alpha is equal to 30, we will have to provide the triggering pulse. So at this instant, we need to provide the triggering pulse for thyristor 2, RB. That means thyristor 2. So at this instant, for a period of 120 degrees, we are providing the triggering pulse for thyristor 2. And again, when R phase is active, we will provide the triggering pulse for the thyristor 1. And again, at this instant called RB phase, we will be providing the triggering pulse for the thyristor 2. And this is IG3 at this instant called Y phase when it is appeared, Y phase when it is appeared, that is from, this is 30 and this is 60. So at this instant called zero crossing plus 30, we are supposed to provide the triggering pulse, and since it is YB, we are providing the triggering pulse for the thyristor 3, IGT3. And then here again another zero crossing, D phase is being appeared, and because of which we will provide the triggering pulse for the thyristor 4, IGT4. And here DY phase. So that is the reason here we are providing the triggering pulse for IGT5. And again at this instant we are providing the triggering pulse for IG-T6. Alright, so these are the triggering pulses, and now let us check out the output voltage waveform. So at this instant called zero crossing plus alpha is equal to 30, we have provided the triggering pulse. So it will be conducting from here, and as I told you, pair of thyristors will be conducting for a period of 60 degrees. So this is your output waveform, and this is due to RY phase. RY phase in the sense R, thyristor 1 is forward bias, which is conducting current through the load, and then Y phase. So because of RY phase, T1 and T6 are conducting. So let me give you the sequence how the devices will be conducting. 6-1 is one sequence, 1-2, 2-3, 3-4, 4-5 and 5-6. This is how the thyristors will be conducting. This is the sequence. And now see, since RY phase is being appeared, RY in the sense thyristor 1 as well as T6 will be conducting. So it will be conducting current through the load in this direction. So here RY phase, let me write it down, 6 and 1 thyristors are conducting, and this is interval 1. And now what is happening? Here zero crossing appeared. At alpha is equal to 30, we are providing the triggering pulse. We should provide the triggering pulse. So since we have provided the triggering pulse because of RB phase, RB in the sense thyristor 1 as well as T2. So thyristor 1 and 2 are conducting in the interval 2 because RB is appeared across the load. And now during interval 3, so here YB phase in the sense this is zero crossing. YB phase zero crossing, alpha is equal to 30 from here to here. YB, because of YB in the sense this is Y phase, T3 will be triggered, and this is B phase, T2 will be triggered. So T3 and T2 are conducting. 2 and 3 are conducting in the interval 3. Yes. So again, here YR phase is being appeared. This is zero crossing, alpha is equal to 30. Here YR will be conducting, and again BR will be conducting, and again BY will be conducting. So like this, so on, the cycle will be repeating for alpha is equal to 30 degrees. And if at all, if you take alpha is equal to 60 degrees, see, for alpha is equal to 60 degrees, this is a zero crossing, alpha is equal to 30, alpha is equal to 60. So it should conduct from here, right from here. And how long it need to conduct? Till here. So this is your output voltage waveform for alpha is equal to output voltage waveform for alpha is equal to 60 degrees, and this is due to RY is appeared across the load terminals. And if it is RY, in that case, which two devices? R in the sense T1, Y in the sense T6. 6 and 1 are conducted. And later, again, after this, Y phase is being appeared. This is 30 and this is 60. So due to YR phase, output voltage will be appeared across the load, and this is YR. So YR in the sense T3 as well as T4 will be conducting. So on, we will be getting the output voltage waveform. So till alpha is equal to 30 and 60, output voltage will be continuous. And if you exceed the firing angle beyond 60 degrees, in that case, firing angle will be, because of which output voltage will be becoming discontinuous waveform. So here, let me check out the output voltage waveform for alpha is equal to 90. So alpha is equal to 90 in the sense, this is your zero crossing, 30, 60, 90. So from this instant to this instant, your RB will be appeared across the load. And it remains 0. It is because, see here, Y phase, another phase is being appeared That means R phase is being reversed bias, thyristor 1 will be turned off. So here, because of zero crossing, 30, 60, 90 at this instant again, output voltage waveform will be appeared. And if you see, output voltage is remained zero from this instant to this instant. It is because, as I told you, whenever firing angle increase beyond 60 degrees, our output voltage waveform will be becoming discontinuous. So that is the thing. This is completely three-phase full converter. And here V0 average expression for full converter. That is, it is conducting V0 average is equal to here 1 by t, 0 to t, V0 of omega t, d omega t. And here, your output voltage waveform will be 3 root 3 Vm by pi cos alpha. This is the final V0 average expression. In the upcoming lecture, we'll be seeing three-phase full converter with RL load. Thank you.